Okay, for number 5, I have to do the derivative. I know what the function is. I'll write this over here. And that's going to be 3x squared minus 1 times e to the minus x squared. Let me write the first derivative down. And that's going to be, let's do the derivative of the first function, which is 6x times e to the minus x squared plus 3x squared minus 1 times derivative of the second function, which is e to the minus x squared times minus 2x. All right, I got problems here. And the problem is I got to factor that guy. And the first thing I would probably pull out is 2x. And I'd pull out e to the minus x squared. And what do you get there? It looks kind of nasty. It really does. And we'll put this down for you. It's good to have a key because you want to check it. And you're going to get 3. Then you get minus. And let's see. That's a multiplication symbol there. I got this part pulled out. Minus 2x pulled out. No, minus, I got 2x pulled out. So you're left off with this. Let me just see. That's going to be plus now. Let me just see if I did that right. So I put minus 1. Yeah, I think I did okay. Let's write this down. 2x e to the minus x squared. And then you can get 3x squared. And let's see what you get there. Plus 2. And I know I made a mistake here. Someone says, how'd you know I made a mistake here? I'm looking at the picture. And this only has 1, 0. So I got to go back and say, you know, I made a mistake. And I want to correct it. I must have made a mistake, by the way. Let's put it down again. Before I do anything, I want to look at it again. I got the 6x e to the minus x squared. Copied it right. I think so. 3x squared minus 1, e to the minus x squared minus 2x. Let's write it down again. So I'm going to factor out 2x. I'm going to factor out e to the minus x squared. And what do you get there? You get 3. Let's see. Minus 3x squared minus 1. Let me just stop for a moment and make sure I wrote this down correctly. Yeah, I think I did okay. Let me write this down now. 2x e to the minus x squared. This is going to be 3 minus 1, which is 4, minus 3x squared. This is more in line with what I expected. And someone says, why is that? I'm seeing 3 extrema in the problem. And let me go through that with you. So one of the extrema I'm seeing over here, it's where x equals 0, by the way. So I can put x equals 0, and I'm just going to put down f of 0. Now this is a min. By the way, it's both global and relative. All right? The other one is going to be where this takes on a 0, and that's not so bad. It's going to be 4 equals 3x squared, or 4/3 is equal to x squared. So I think I got these two over here. I get a nice sense of symmetry over here. So I'm going to put down, it's going to be 2 over root 3, f of 2 over root 3. What's this one over here? Minus 2 over root 3, f of minus 2 over root 3. All right? These are global maxims. Both of them, same thing, or relative max. All right? So what I want to do is, before I go to the next thing, I want to see if I got it right. All right? Assuming, what do you mean you got it right? Was I able to get the derivative right? And I'll be honest with you, if it's not correct, what follows it would be a waste of time. So 2x e to the minus x squared, I do see that, and 4 minus 3x squared. All right, I want to see if I got the local maximums at plus or minus 2 over root 3. I got those. They're global. They call them local here. They're also local. And local minimum at 0. I got that. That's good. Now, someone says, is there something else? I want to read that again to you. It says, given the graph, we did that, indicate the transition points. Right? So there's something else I got to do. And I'm wondering if it's been done over here. And yeah, you know what? These look like they might be really tough to come up with. Let's do that, though. And they look really tough. All right, but let's see if we can do that. I got to get that second derivative down. So let's write this over here. So the first derivative, y prime, whoops. I'm going to multiply it out for you. It's going to be 8x e to the minus x squared minus 6x cubed, right, 6x cubed, that's not bad. And let's see, e to the minus x squared. I'm going to write it a little differently. I'm going to write it as e to the minus x squared times 8x minus 6x cubed. All right? I'm going to take a derivative of that. I'm going to clean it up in a moment, though. The first function, which is e to the minus x squared, times with the second function, which is 8 minus 18x squared, plus the second function, which is 8x minus 6x cubed. Boy, that looks really nasty, doesn't it? Times the derivative of that e to the minus x squared, which is e to the minus x squared times minus 2x. All right, let's keep going. I'm going to factor out e to the minus x squared. And you get 8 minus 18x squared. And then what do you get? You get minus 16x squared plus 12x to the fourth power. Fourth degree polynomial. I'm going to keep rewriting it, and then we'll check the key in a moment. I'm going to write down 12x4. I'm going to say minus, I got the squares now, right? 18 and 16, 34. X squared, well, that's nasty. And then plus 8. I'm going to factor a 2 out from that. And you get 6x4 minus 17x squared plus 4. All right, yeah, I'm saying, you know, the nasty. So let's take a look and see how we did. So I'm seeing the e to the minus x squared. I'm seeing the 2. I'm seeing that. 6x4. I'm seeing that. Minus 17x squared. I'm seeing that, and 4. Now, by the way, someone says, what's next you're going to do? I'm going to try to figure out where this thing takes on a 0. All right? And by the way, I'm expecting to see certain places, and I want to point out, you know, concavity changes here. That's one point. I'm going to say concavity changes over here somewhere. That's another point. Again, I'm not saying exactly where they are. Maybe another point there, and then a point over here. So I'm actually expecting 1, 2, 3, 4. 4 different solutions in the problem. And I'm expecting to see that, and I'll tell you why. I'm a fourth degree polynomial. The way I'm going to do that, I'm going to substitute, I'm going to say u is equal to x squared. And what do you get? You get 6u squared minus 17u plus 4 is equal to 0. Well, let's write this down. U is going to be equal to quadratic formula. Let's see what you get there. I'm going to need some room over here. I might have to go over to another thing. Let me see. Twice the a, which is 12. And then I bring the, let's see, on the top it's going to be the opposite of b, which is 17. Plus or minus, this is the tough part. I got to do it on the side. So it's going to be 17 squared minus 4 times 6 times 4. All right, a little bit of arithmetic. 17 squared. Well, 10 times 17 is 170. Let's see, 7 times 10 is 70, and 7 times 10 is 49. So 289. And then I got 16 times 6. That's going to be 60 and 36, which is 96. All right, let's take a look. 193. Let me just check again. Let's see, 104 and 89. Yeah, 193. A very nasty number, no doubt about it. It's going to get nastier because I got an x squared there. So x squared is actually equal to, it's actually equal to u. It's going to be 17 plus or minus the square root of 193 over 12. By the way, the square root of 193 is smaller than 17, so I'm not worried about complex numbers. There's going to be four solutions to the problem. What are they going to be? X going to be equal to plus or minus 17 plus minus the root of 193 over 12, all right? That's the numbers going over here. I want to point out, not that I want to do it, but you could write these numbers in order if you wanted to, but the bottom line is there's 4 points over here, right? 4 points, as we expect. A number there, number there, number there, number there. What are those numbers going to be? Well, let's start off with the most negative number. That would be 17 plus the root of 193 over 12. The next one's going to be minus square root 17 minus the root 193 over 12. And I think you get the idea, one after another. A good deal of symmetry on it, all right? Like, for example, the positive this would be there, the positive would be over there. Very simple. However, the numbers are really nasty numbers. Thank you.